Hey guys, and welcome to my Git Gud Workshop. I'll be giving you some basic information about Git, but also the workflow that we decided on for the semester project, and why it's good to have a solid workflow. I'll be going through the basics of Git, and you probably know a lot of these things already, but that's alright. I'll also be going over why you should consider using the command line tool instead of a graphical version of Git. Then I'll be talking about the workflow, so how Git saves the history of your code base, and also some trunk-based development. Then I'll show you some basic information about the setup and how you should clone your repositories, because there's a slight difference. And at the end, I'll actually be going through the different examples I gave you in the Git Gud document. And I'll be live coding and drawing out some of the things as well. So what exactly is Git? Git is a version control program used to keeping track of changes to a code base. One of the main features of Git is the commit. A commit just defines a new version of your code. When you've done code changes, you'll commit them, and this commit will then have a unique ID called the hash, and this hash will represent a new version of your code. Along with commits, there's also branches. Branches are used to encapsulate commits. So when you pick up a user story from, let's say, Jira, you'll create a branch belonging to this user story, and then you'll do all the code changes you need to do within that branch. You'll probably commit one or even multiple times before you're done with your code. Once you're then happy with your code, you can merge it into the codebase. But what exactly is meant by the codebase? Well, by the codebase, that would be the repository. And you have both a local and a remote repository. The local repository is just your local version of all the code that exists. The remote repository will then be a repository that isn't on your computer. This would most likely be something like GitHub, GitLab, or Bitbucket. And all of these services essentially just set up repositories on their servers that you then connect to. And you can push and pull from into their services. This is why a lot of people get confused between the difference between Git and GitHub. But Git is really just the program itself, whereas GitHub and the other websites are just services that set up remote repositories for you. And then they have a nice website with a graphical user interface on how you can interact with that repository. At the bottom of my screen, you can see the workflow of Git. When you do code changes at first, your files will be considered untracked. And this means that Git doesn't really know or care about your files. If you need Git to actually care about them, you'll add them by running the git add with either a dot or the name of the files you want to add. This can be either file names or folders. Once you've added files, they'll be considered staged, or they'll be in the staging area. This is actually very useful because sometimes you don't want to add all the files. If you have files that you've used for testing or files that don't need to be part of the codebase, you can just not add them and they'll forever be untracked. Once you've added them to the staging area, only the staged files will actually be committed once you run your commit command. And once you do that, they'll be added to the local repository, so your version of the codebase. And then to tell the remote repository, you just push your changes. This will tell the remote repository like, hey, I did these code changes on this branch. It'll then be visible on GitHub. I have an opinion that some people don't agree with, but I think everybody should be using the Git CLI, or the command line interface. If you don't know what that is, then I'll just drag it on screen. The CLI can really be used through any terminal, but if you install Git on Windows, it'll come with Git Bash, which in my opinion is by far the best program. A lot of people are scared of using terminals, but as developers, we really shouldn't be. But I have three main points as to why you should use the CLI instead of a graphical interface. The first one is that you have so much more control when you use a CLI. In the command line, you run the commands individually, so you know exactly what every step will do, which actually makes it harder to make mistakes, and it makes it more clear what exactly you're doing. That kind of brings me into the second point, that GUIs are very different. A lot of GUIs actually try to simplify things so much that they combine multiple Git commands into a single button. And this kind of forces you to use the workflow that the developers of the GUI intended, instead of using the workflow you might want to do. If you look at the drawing of the tree over here to the right, this is an example of what can happen when you use either a poor workflow or if you use a GUI that just expects you to use it. It can be really cluttered, and sometimes the GUI will actually do things that you might not want to do, such as if you click update, it might just merge master into your branch and create all these weird connections back and forth, which kind of goes against the workflow that we're trying to get. That also brings me to my third point, which is using the IDE. If you're using an IDE like VS Code, IntelliJ, or any editor really, they probably have a version control integration, which is usually Git. And using those can be kind of useful, but it comes with the same downsides as using the actual GUIs. You don't know how they're implemented. It also has the additional downside of if you ever switch your IDE, if you go from IntelliJ over to Visual Studio, you might actually have to learn an entirely new program just to use the same program. History. The Git history is really just an overview of all the commits and branches that's been in the codebase over time. There are two main types of history. There's the nonlinear one and the linear one. Over on the right here, we can see the two different kinds. On the left, we can see the nonlinear one, which allows you to create branches and merge back and forth as you please, and then merge them into master whenever you're done with them. Then there's the linear one, where you can also have as many branches as you want, but in the history it looks like only one branch exists at a time. This makes it a lot easier to see exactly which commits and which changes are within which branches. So it makes it so much easier to get an overview. And the workflow for these two are really the same. You may think that only one developer can work at a time on the linear one, but that's not true. It's all about just keeping your branch up to date. And to do that, you'll actually be using rebase. You've probably heard about merge before, but maybe not rebase. That's why I'll be drawing both of them for you. Let's say we have a master branch right here. Then I create a new branch right here with 2 commits on it for my new features. But then before I'm done with my code, someone actually adds something to the master that I would like to have part of my branch as well. Maybe I need some of the functions they added or something like that. So if I were to merge, I would merge master into my branch so that I would have the changes. And then I could continue working, maybe add a 3rd commit. Then once I'm happy with it, I would merge it back into master. And as you can see, it kind of creates this back and forth motion where you first merge master into your branch and then you merge it back. So that is how merging works to update your branches. The second way of doing it is actually the rebase, which is the one I prefer, and which is the one creating the linear history. Let's say again that we have a master branch right here. I create a new branch and I add 2 commits to it. But then before I finish, someone adds a commit to master. Now, instead of merging master into my branch, I can actually take my branch and rebase, which does exactly what it sounds like. It moves the base of the commit. It moves where I merged from, moving it up here. So now I've actually changed the history of Git, because before it thought I merged from down here, but now it seems like I merged from up here, or I branched instead. Sorry. And now when I'm done, I can actually merge it into master. As you can see, in the rebase, we actually get these nice linear and single branches. And one of the nice things is actually that GitHub can do this for you automatically. But if you prefer, you can also do it through the terminal. Because our teacher mentioned it, I'll just quickly go over what trunk-based development is. Trunk-based development is really just working on a single trunk, which in our case would be our master branch. So working from one source of truth. And within trunk-based development, there's really 2 kinds of development, which you can read more about on the website at the bottom. But one of them is essentially for small teams. So if you're just 2 people, you can just work in pair programming and commit it directly to master. But as soon as you're more than 2 or 3 people, it can create conflicts, which is a problem. That's why we should probably use the scaled trunk-based development, which means you will not be working directly on master, but you'll be creating short-lived feature branches. Each of your tasks or subtasks will be a branch of itself that you will eventually merge in. And you don't have to worry about the releases up here because we don't care about releases. Before you start using Git Bash, there are a few things you have to configure. The 2 main ones are the name and email. These will be shown in all of your commits, and the email will also be used by GitHub to link it to your account. The third thing is the editor. By default, Git Bash uses an editor called Vim, which has a really steep learning curve. That's why I suggest you either use Notepad or VS Code. When you clone the repository, you can do it either through HTTPS or SSH. The difference is that HTTPS uses your GitHub email and password, whereas SSH, you have to generate a SSH key and link it to your account. So SSH is considered the best practice way of doing things, and it's much safer as well. All right, you've made it this far. So now I'll go through some of the examples I have. I have 4 examples, and then I'll go over how to resolve conflicts. The first example is just how to create new branches and add some code. The second one is how to add commits to an already existing branch. The third one is how to add changes to a previous commit, which can be really useful sometimes. And then the fourth one is how to rebase branches. So the first one here on how to create a new branch and start adding code. On your master, you should always pull before you create new branches to make sure you don't have any conflicts. This will actually resolve a lot of the conflicts that often show up just because you have the newest version of the code. You can jump to a new branch by either saying checkout-b, or you can say git branch and then the name, and then go to it afterwards. I usually just say git checkout-b, then the name of the branch. Then you'll simply add your code, commit it, write a message. And then the first time you push it, you have to say -u origin and then the name of the branch. This tells GitHub that you would like to create a new branch in their repository with their name, where origin refers to GitHub or GitLab or whichever remote you're using. So let's try this in practice. You can just go to the folder, right click and say git bash. That's how you have it. So if I want to create a new branch, I'll simply say git checkout-b and then new cool branch. And as you can see right here, now I'm on my new branch. It's very simple. Then if I were to do some code changes, just go in here, write some amazing code, go back to git bash. If you say git status, you can now see that my file is currently untracked. So it's not in the staging area yet. So if I say git add, this one, now when I say git status, you can see that it's green because it's currently in the staging area. So it's ready to be committed. So to commit it, I would simply say git commit. And this is where you would probably get your Notepad or your VS Code, whichever editor you set. And then for good practice, you make a headline, add new feature. And then on the third line, you should probably write something like whichever ID you used. This could be the greenhouse number 123. And then I added a new feature. Then you save and quit that. And then you would simply do git push -u origin and then the name of the branch. And as you can see now, I have my new branch pushed to the repository. So if I were to go to the GitHub account, I could see it there and I could create a pull request for the other people to look at. So if we go back to my slides, then my second example is how to add a new commit to a branch. Let's say someone reviews my code and finds some mistake I've made. Well, that's very simple. All you do is you just go back to your code and, oh no, I had a typo. I had to do this as well. So here you can see again, oops, it is again untracked. So you just do exactly the same thing. You add it, you commit it, and then fix. But this time you can just say git push. You don't actually have to do the -u origin again because it remembers the origin it said last time. And on my slides, you can also see an example of how to do it. If you're on the master branch, you have to do git checkout, then the name of the branch first. But if you're already on the branch, you can just add commit and push it.